Today's experiment is estimation of weak acid by conductometry. To estimate the amount of weak acid present in the given solution, a standard ammonium hydroxide solution of known strength is provided. The addition of weak base to the weak acid is accompanied by slight increase in conductance due to the dissociation of ammonium acetate formed by chemical reaction. After the complete neutralization of the acetic acid by the ammonium hydroxide, conductance remains same due to feeble ionization of ammonium hydroxide. Now, let us see the demo of this experiment.
Hello students, now I am going to give you the demo of the experiment estimation of weak acid by conductometric titration. Let us first show you the apparatus needed for the experiment. So here we have the conductometer. This is the conductometric cell which is immersed in deionized water. When not in use, this cell will always needed to be immersed in deionized water. So here we have the burette, the pipette and the funnel to fill up the burette with burette solution. The reagent that we are going to use are the sample which is the weak acid of unknown strength and the burette solution which is the weak base of known strength. So to start with, let us first wash all the apparatus. So you need to wash the burette and the pipette and first with tap water and then with the deionized water which is taken in this bottle. Now after that you have to wash the burette with a little bit of burette solution and the pipette with a little bit of pipette solution. This burette is already washed. Now I will show you how to fill up the burette. So you put the funnel on top of the burette and then hold the funnel like this so that there is a gap, right? And then fill up the burette with the burette solution which is the weak base. Now you have to be very careful that there should not be any air gap in this part. So now you can see there is a air gap. So you just open the knob little bit and then close it so that the air gap is gone. Then you have to adjust the volume here so that the lower meniscus of the burette solution is on top of this 0 mark, and then that way you can fill up the burette. While adjusting the burette solution, so you have to bring the burette so that the 0 mark is at your eye level, and that is how you have to adjust the volume of the solution in the burette. So we have taken 40 ml of the analyte here in the beaker, and now you can see that there is one magnetic bead kept in this box. That also you wash with the deionized water. Wipe it off, the extra water, and then gently put it into the solution. Now you keep the cell inside the beaker but above the solution. It should not be immersed into the solution. In this position there is a stirrer button, you can see. So we will just stir this solution for 45 seconds, and after 45 seconds of stirring we will turn off the stirrer immerse the cell back into the solution and take the reading of the conductance. So after 45 seconds of stirring, which is over, so we turn off the stirrer knob and then immerse the cell back into the solution. So here you can see the reading. We'll wait here for some time to get a stabilized reading. Now in the meantime, let us show you how to fill up this tabular column. So this is estimation of weak acid. Here it is acetic acid given. So you just write that. And this reaction is a neutralization reaction. You have to write the actual reaction also. Since it is a weak acid and the weak base, with weak base we are doing the titration. The weak base given is ammonium hydroxide. So we write the reaction. So we will get ammonium acetate plus water. Now you can see that the reading is still 0.147, meaning it is stable. So we will write here, this is volume of base, that is Cv. We have not added any base, so we will write 0.0 here, and then correspondingly the conductance is 0.147. So now after taking the first reading, you have to add 1 ml of the base from the burette solution into this beaker. So what again we are doing, we are lifting up the cell, but remember the cell should be inside the beaker but above the solution, and then you keep the burette here and add 1 ml of the weak base inside the beaker. Put the burette back into its stand and then again stir it for 45 seconds, and after stirring of 45 seconds again immerse the cell back into the solution and take the reading. So after 45 seconds of stirring, you can see the reading has increased from 0.147 to 0.192. So here again we will write volume of the base added 1.0 and corresponding reading is 0.192. So here you can see we have taken the reading for each ml addition of the base. We have taken the reading. So here if you see when we have added 10 ml of the base, the reading is 0.677. For 11 ml addition of base, it is 0.678. So there is not much change in the two conductance values. So when you see that kind of reading where two consecutive conductance values have not changed much, after that you take 6 more readings and finish it off. The experiment will be over. Now here you have to do the volume correction also, because the conductance is so less, so we have to do volume correction. So what we will do is Cc is this conductance 0.147. So we will write that into Cy, that is the volume of the base Cv, that is the volume of the base added. For first it is 0.0 plus 40 divided by 40, which is 1. So we are multiplying 0.147 by 1. So it will be 0.147 only. So since there is no addition of volume, so no volume correction. Now we come to the second. So here it will be 1.0 plus 40 divided by 40. So it will be 0.192 plus 41 divided by 40. So we'll just do that. 41 divided by 40, which is this, into 0.192, which is 0.1968. So for each reading we have to do this volume correction.
After the values are tabulated, a graph is drawn taking the volume of base in x-axis and the corrected conductance in y-axis. The point of intersection of both the lines gives the endpoint. From the endpoint, the amount of acid is calculated as shown in the next slide.